All right, we're going to do another type of factoring today. And it's factoring by grouping. Okay, we got one more to do after this, I believe, at least in this section. But let's do this one. We're going to start right off with an example. And it's example 14 if you're following along in the book. I'll just write it down. And it says factor completely by grouping. It tells you how to factor it. If you look in the book, they're going to ask you to do a whole bunch of factoring. They may not say factor this by grouping. You have to look at it and recognize that you need to factor it by grouping. So what we're going to do, I'm going to give you a worksheet today. And the worksheet, the problems don't look exactly like this one. But you're going to have to be able to do this in order to be able to do the ones in the worksheet. Okay? So we're kind of starting off a little bit easy, and we'll work our way up. So we will have one example. We'll do 3 examples today. The third one will look just like the ones on your worksheet. Okay? I'm not giving you ones from the book. They only give you just a handful in the book. I didn't think they give you enough. That's why I made the worksheet for you, okay, so you could have a little bit more practice. So this looks kind of weird, but they do this for a reason, and I get it. And they put an x right there, plus parentheses, and a x squared plus 2 again. And then they put times 3. You could have written this with the x out in front and the 3 out in front. That's probably, I'll tell you what, or I'll just do it like that. Just looks a little, to me anyway, just looks a little neater having those things out front instead of in the back. All right? So what we're going to do, it's called factoring by grouping. We're not really grouping these. This is just like a little bit of practice before we actually start grouping them together, because they're actually kind of already grouped. You'll see what I'm talking about when I get to another example. But if you take a look at this right there, okay, and then look at this right here. Do you see anything in common with those two things? Because that's what we should always look for, right? Don't we always look for a common factor? All right, just like these. We need to look for a common factor. Is there anything in common? Now, the thing that's in common, and there is something in common, okay? The thing that's in common with this is a little bit different than what you just finished doing, finding that greatest common factor stuff, right? But there is something in common. So what's being multiplied here? Well, this x times this parentheses. What's being multiplied by over here? That 3 and what? That parentheses. So what's in the parentheses? X squared plus 2 here, and what else? X squared plus 2 here. So they're both the same, aren't they? So is there anything in common with both of these yellow rectangles inside those? The parentheses, the x squared plus 2 is in common, isn't it? Okay, so we're basically going back to the beginning of our factoring and just factoring out a greatest common factor. Excuse me. So let's do that. Let's factor out a greatest common factor. What's in common with both of these things? Well, there's an x squared plus 2 that's in common with both of them. Wouldn't you agree? There's one here and there's one here, right? It's a little bit different because usually we have like a 2 that's in common or a 5 that's in common or something like that. But in this one, it's a little bit different. What's being multiplied? What's the same thing that's being multiplied by something in here? The x squared plus 2, right? We got one here, we got one here. So that's a greatest common factor. Make sense? Okay. What's left over if I factor it out? If I factor x squared plus 2 from this, what am I left with? Just an x. So I put down an x. We good? All right. Then we put a plus because of this one right here in the middle. And then we factor out that greatest common factor. We factor out, or we divide out, that x squared plus 2. So what are we left with if I take out an x squared plus 2 from this? A 3. And now it's factored. Okay? And that's our answer. Because what did they ask you to do? They asked you to factor it. They say factor completely by grouping. We didn't really group it. I'll show you in a second, grouping it. But that's what it would be. Make sense? All right. Yeah, that's a little bit weird. You probably won't be doing a whole lot like that. But what that's going to do, this is just setting the stage for what we're going to do next, okay? So you probably won't see a problem just like that. But you will see some problems where you're going to have to use what we just did right here. I hope that makes sense. I don't know. It will once you start doing these problems. Let's do the next example, and that's example 15. Kind of the same thing. It's not a whole lot different. There's a little more stuff to it, but it's basically the same thing. So let's write it down. So 3x minus 1 parentheses squared, and then times x plus 2. That's to the fourth. And you got a plus sign, and you got a 4. And then you got a x minus 1 cubed. And then you got a x plus 2 cubed. All right, look at this crazy thing. Again, what do they ask you to do? They ask you to factor. And again, it says factor completely by grouping. What in the world are we going to do here? Well, let's do this. Let's take a little bit at a time. Let's take a look at just the number that's out in front. I got a 3 and a 4. Is there anything in common? Anything divide evenly into 3 and 4? No, there's nothing. Okay, so I can't pull out a 3 or a 4. I just leave that where it is. Let's go to the next one. This one right here. I got an x minus 1 squared. That basically means I got 2 x minus 1s, don't I? All right, I got x minus 1 times an x minus 1. Do I have any x minus 1s over here? I do. But I got 3 of them, though. So how many are in common with both of them? Just 2 of them, right? So what's my greatest common factor so far? It's x minus 1 what? Squared. Exactly right. Does that make sense? All right, because I see what's in common with both of them. All right, I take the most that's in common, and x minus 1 squared is over here, and there's actually an x minus 1 squared over here. I got a little bit left over, though, don't I, on this? But that's what's in common with both of them. All right, let's do one more. This is x plus 2 to the 4th. I got an x plus 2 to the 4th here, and I got an x plus 2 to the 3rd here. What's in common with both of them with that x plus 2? The cubed, right, x plus 2 cubed. Because there's 4 of them here, right? 3 of them here. So how many in common with both of them? There's 3 in here and there's 3 in here, right? There's a little left over, right, on this one, but that's okay. But there's 3 of them in common with both of them. So we're going to write, we don't just write a 3. What do we write? X plus 2, what? Cubed. So that's in common with both of them. Right? It's the same idea as our normal, everyday greatest common factor. But it's stepped up a little bit, right? It's just a greatest common factoring 2.0 or whatever, okay? It's just a little bit more intricate than what we had before. So that's in common with both of those. So what do we do after we pull that out of there? Put a big old parentheses, and then we take this whole thing and we divide it by this, right? We pull it out. We divide it out. Now the 3 is just going to stay there, right? Because you didn't divide anything. You didn't have a greatest common factor with 3, so the 3 just stays there. What about this, though? I had an x minus 1 squared, and I pulled out an x minus 1 squared. What do we have left? Well, you have just a 1, okay? Just a 1. So x minus 1 squared divided by x minus 1 squared is the number 1. Do we need to put a 1 there? No, because it's being multiplied by the 3. I can just keep it like that. What about this next one? What did I pull out of this? I pulled out an x plus 2 cubed, right? So this means I got 4 of them. I took out 3 of them. How many do I left over? I got 1 of them. 1 what? 1x plus 2, correct. Does that make sense on how I explained it? So I've got an x plus 2 to the 4th divided by x plus 2 to the 3rd. That means I just have an x plus 2 to the 1st left over. I don't need to put the 1st. I just leave it like that. Okay? Let's do another one. Plus. Now, I didn't pull anything out for the 4, so I just keep the 4 there. What about the x minus 1 cubed? What did I take out of it? What did I divide out of it? An x minus 1 squared. So what's x minus 1 cubed divided by x minus 1 squared? It's just x minus 1. Very good. You're getting the hang of this. And now, what did we take out of this x plus 2 cubed? X plus 2 cubed divided by x plus 2 cubed is just a 1. Do we need to put the 1 there? No, because it's already multiplied by all that stuff. And now I close my parentheses. And let's see. Oh, I see what they do. We're not quite done. We've done all the factoring part, but we need to simplify this. See all this stuff right here? We can make that look a little nicer. Okay, what do you think I can do with this stuff? Take that 3 and do what to it? Distribute it through, okay? And you're going to see in a second why we're going to do that, because this is not completely simplified, all right? We always need to simplify everything. Over here on the left-hand side, I'm good with that. I can just write this and this, okay? But let's see what else is in here. So what am I going to do with that 3? I'm going to distribute. So what do I get? 3x plus 6. And what can I do with that 4? Distribute that through here. Now, why in the world would I need to do that? Because I would have like terms I can add together. You see that? So we can make this a little simpler than what it was originally. Okay? You understand why we're doing it? Over here on the left, I'm just going to keep all that stuff exactly the same. So it's x minus 1 squared, x plus 2 cubed. All right? And then let's figure out what's left in here. Let's add some like terms. 3x plus 4x is 7x. Okay? And then positive 6 minus 4 is plus 2. And that is how you'd want to write your answer. Okay? Make sense? It's not too bad. But the thing is, this problem right here, we're going to start with something else in order to get to this. All right? It may not be that complicated, but let's do another example. Everybody write that down? Okay. So let's do, I only have one more example to do, but maybe we'll do 1 or 2 problems from the worksheet after I give it to you, okay, just to get you going a little bit. Again, this is example 16. And again, it says factor completely by grouping. Now this time we're actually going to group stuff together, and I'll show you what it means by the grouping. So here's what they give you. X cubed. So this will look a little different than the other problems that we just finished doing. But again, those other problems are just kind of leading you up to this. All right? We just took little stepping stones to get up to this. Now we're at the mountaintop right here. Let's take a look at it. Very first thing we should always do is to see if there's a greatest common factor. Is there anything in common with all 4 of these? Well, I got an x cubed, x squared, x, but I don't have any x here. So are there x's in common with all 4 of them? Nope. I got a 2, 4, and 8, so 2 must be in common with everything, right? No, because there's no 2 right here. So that's my only choices, right? So is there anything in common with all 4 of them? There's not. So I can't factor out a greatest common factor. But I can do this. Now watch. They kind of rig these things for you so it works real nice and easy. Here's the grouping part. Do you see right here? Is there something in common with just the first 2? There's more than just an x squared, right? There's an x squared in common with both of those. Would you agree? Okay. Let's take a look at the last 2. Is there anything in common just with the last 2? A 2. Agreed? All right. Now, you could look at the 2 middle ones and say, oh, there's a 2 and an x in common with the middle ones, okay? You could group them that way. Or you could look at the second one and the fourth one, and you're like, hey, there's a 4 in common with both of those. That's very true. But what we're going to do, they're going to make these things kind of the same, all right? So here's what I would do. And this is what the book is going to do. They're going to group them like this. Now, doing that, did that change anything by me putting parentheses around it? No, because these 2 are still being subtracted from each other. These 2 are being subtracted. You still got a plus, right? I didn't change anything with that. Agreed? All right, I think that's called the associative property. Do you remember doing that back in Algebra 1? I always hated that stuff, but I think that's what it's called. All right, so it doesn't matter how you group them up. This is the way we're going to group them. So we said that there was something in common with these 2. So let's factor this part of my problem, okay? So what's in common with both of these? We already said it. There's an x squared. So let's factor it out, see what's left over. So if I factor out an x squared from this, it's x cubed divided by x squared, which gives us x. Bring down the minus. What about this? Yep, keep the 4 there because there's nothing I could pull out of the 4. And then I got an x squared divided by x squared. What's that? It's a 1, right? 1 times 4 is just 4, and I can leave it like that. Would you agree that this is the exact same thing as this first parentheses right here? Yeah. Absolutely. Now I'm going to put a plus, and now I'm going to factor something out of this. So what's in common with both of these last two terms? There's a 2 in common. So factor out a 2, put a parentheses. If I take this and divide it by 2, what am I left with? Left with, no, not a 4. I divided by 2. Took this divided by 2, which is 1, and x, and then I just have a left, I'm left over with an x. Just put the x right there. Minus, take this, factor out a 2 from this, or divide this by a 2. What do you get? You get a 4. Okay? Would you agree that this parentheses and this thing right here is exactly the same thing? Yeah. Same thing, right? Because if I distributed, I would get this. But now, do you remember the two problems we did before, especially that first one, that first example? Do you see something now that's in common with both of these? The x minus 4 is in common. Do you see that? Do you see why we did that first example? Because now, this looks like that first example. So now, if we take a look at this, and we take a look at this, is there something in common with both of those? Yeah, the x minus 4. So what are we going to do now? We're going to pull out an x minus 4. So it's kind of like a multi-level factoring type problem. So now I'm going to pull out an x minus 4. What are we left with? If I pull out an x minus 4 from this, I'm left with an x squared. Then put that plus. Okay? And what if I pull out an x minus 4 from this? I'm left with a 2. Can you factor anything else from here? What about this x squared plus 2? Can you factor that? Is that a difference of 2 squares? No. Is it a perfect square? No. Is it? No. There's nothing. You can't factor this. So we are done. This is factored completely now. Okay? It's completely factored. And that's what they ask you to do. I didn't write it down, but they write factored completely by grouping. And that's how we do it. Make sense? Yeah. All right. Let's do this. Tell you what, I'm just going to do the... I'm not going to give this worksheet out to you just yet. But I will do the first problem with you. I'll do a couple problems. I'll probably do the first and the third one, I think. All right, so I'm going to give you this in a few minutes, but just not right now. So this is number 1 on the worksheet I'm going to give you. So write it down, and then you can try it yourself when you get the worksheet. That's 64 r squared plus r minus 8. Now this is a little bit different. You know how we did that first 2, then the second 2? We grouped them together. See how we did that? This one doesn't work exactly like that. Well, actually, no, it does. It actually works out a little easier. This one's a little bit easier than what we just did. Okay? So let's do that. Let's group it like this and group it like this. Okay? Let's do the first one. Is there anything in common? An 8 and a r squared. Okay? Very good. Nisi, I heard you. Just saying it so everybody else could hear it. So let's factor out an 8, and we're going to factor out an r squared, because that's in common with both of these. Let's figure out what we get left over. So 8 divided by 8 is 1. R cubed divided by r squared is r. Minus 64 divided by 8 is 8. And then r squared divided by r squared is 1. 1 times 8 is just 8. You with me? Can you factor out anything from this r and this 8 right here? No, you can't. So you just write it down as r minus 8. Seems kind of random, but now you look at this next step, though. It's not random, is it? They rigged this thing, didn't they? Okay, they rigged this because what's in common now with this thing and with this? Okay, the r minus 8. So let's do that. Let's factor out an r minus 8. What are we left with? We're going to take this one right here. If you pull out an r minus 8, what are we left with? 8r squared plus, and then we factor out an r minus 8 from this, or again, we divide, and so it's r minus 8 divided by r minus 8, and we get, Carter said it, it's a 1. Don't forget the 1. Don't just think it goes away. It doesn't go away. Remember, it's a 1. Everybody with me on that? Yeah. Can you factor any more? 8r squared plus 1. Can you factor that thing? No, it's not any of our special factoring. It's not a trinomial. It's not a difference of two squares. It's none of that stuff. So we are finished. That's it. And that's how you do it. Now the book, or the worksheet, the answer key, they actually write it like this. And I'll tell you why they do it. You don't have to. The way we did it is perfectly fine. Okay, if you wrote it like that, you'd get it right. But they wrote it like this. I'm going to put an or. Okay, this or this. Why do you think they wrote it like this? Right, the squared is first, okay? They usually, it's called descending order, right? You put things from the highest power down to the lowest. So they figured, just make it look a little nicer if we put the highest power first. That's the only reason they did that. But really, these are exactly the same thing. Okay, if you would have kept it like this with the r minus 8 out in front, it's perfectly fine. I'd accept it. It's probably how I would just write the answer, okay? But this is, if you know, when I read off the answers tomorrow for you, I may read it off like this. And you have to just understand it's exactly the same thing. We good? Let's do another one. Let's do number 3. So it's 12x cubed plus 2x squared minus 30x minus 5. Up to this point, we've always had a plus right here, haven't we? Right here. Okay, that first, second, third number right there was always plus, so you got a plus here. You had a plus right there, and then you had a plus right there. Okay, everybody see that? This time, scooch on down. There we go. This time it's not a plus. This is where it gets a little bit confusing for some people, but it's not super, super hard. Remember how we put the parentheses around this? Remember that? But you got to be very, very careful in this next one. When you have a minus right here in front, okay, you cannot just put a parentheses like this and just move on. Because look what we just did. If I put parentheses, this would be negative 30x, and it should be what? Plus 5, right? But the original problem wasn't plus 5. It was what? Minus 5. So what are we going to have to change to keep it equal to the original problem if I put parentheses here? Yep, or just take this minus and make it positive. If it was positive, we would have made it minus. Okay? Because, why did we do that? Because if I distribute this negative through here, that's negative 30x minus 5. Isn't that what the original problem was? Yeah. All right, so we have to make sure that when we put parentheses around this, it's still equal to what the original problem was. Over here, let's go to one of these other ones. Like right here, putting this parentheses right here, isn't this still positive 2x minus 8? Yeah. Okay, because this was already positive. But when they put a negative here, you have to be very, very careful, and you got to put parentheses around it, but you got to make sure it's equal to what we started with. So now you had to change this. I didn't change this because it's still minus 30x, and then it's minus 5. Everybody see that? That's the key when you have a minus right there. That's why I picked this problem to do, all right, so that you can see that. Now let's go ahead and do the grouping stuff like we just did. Well, we actually just grouped it, but let's do the greatest common factor stuff. Let's take a look at this. Let's do this a little bit quicker. What's in common with both of these? A 2 and an x squared. Factor that out. What do you get? 6x plus, take this divided by 2x squared, you get a 1. put a minus. All right. Now, what do we have in common with 30 and 5? Well, 6 doesn't divide into 5. I know what you're thinking, but 5 divides into both of those. It divides into the 6 times, okay? But 5 divides into both of these. And so what do we get? This is going to be a 6x, and this is going to be a plus 1, like this, okay? Is this the same as this? Yeah, negative 30x, negative 5. Whoops, I lied. Yeah, that's right. That's still right, isn't it? Negative 30x, negative 5. Yep, that's negative 30x, and that would be negative 5. Yep, so we're good. Now, take a look. Again, these things are rigged, aren't they? They're not. Somebody didn't just throw random numbers down and say factor it. Okay, this has got an x or a 6x plus 1. This has a 6x plus 1. All right, and so that's our greatest common factor with this right here. So let's factor out a 6x plus 1. Let's figure out what's left over. If I take this whole thing, right, we're looking at this whole thing right there. If that whole thing is being divided by 6x plus 1, what are we left with? It's 2x squared, okay? Put a minus. What if we factor out a 6x plus 1 from this? What are we left with? A minus 5, okay? And that is my answer. Now, the book, what do you think they do? Or it's not the book, it's the worksheet. They put 2x squared minus 5 first, and they put 6x plus 1 next. Perfectly fine. It's okay if they do that. But, you know, I did the work. It's there. It doesn't have to be in that order. This is good for me. All right? That's how you do them. So it's a little harder than what we just did, right? It's a few more steps. You got to think a little bit more. But that's all right. That's what we're here for, right? We're here to learn more and more and more. Okay. We good with that? All right, I'll give you the worksheet out, and I'll give you the rest of the time. Well, 4 minutes. It's due for homework, okay?